So this is a little video for MYP4 just to explain or introduce the summative task Maxbox. So you start off with a piece of A4 paper and you can look up the dimensions of that, and you cut square corners from it, so little squares on each corner, length X, whatever that might be, to form an open top box. So X could be that you clip off 3 centimeters from each corner, or 5 centimeters, or whatever, and then you fold them up and it makes this box. So the height of the box is X. The width of the box that way is, depending on whether you want to call one of them width and one of them length, but let's call this the width. So it's whatever the A4 paper was minus the 2 little X's that you clipped off, and then let's call it the length the other way of the box is the dimensions of the A4 paper that way minus the 2 little X's that you clipped off. So you can work out from what you clipped off what the height, length and width of this box is, and then the volume of that box will be the height times the width times the length. And your objective is to investigate how to maximize the size or the volume of the box. So clipping off different sizes of X will give you different kinds of boxes. You could get a quite wide flat one, or you could get a very tall box by clipping off a big X. There's obviously a maximum amount of X that you can clip off, which is the shorter length, or half of the shorter length of a piece of A4 paper. So you're trying to make the box with the biggest volume. So to get a good score in criterion B, that's investigating patterns, I'd want to see some spreadsheets, so different values of X's in a column, and then different heights and lengths and widths of the box that results in 3 further columns, and then those things multiplied out to give the volume in a 5th column. And then maybe you could create some graphs from that. So going across on the horizontal axis, you could have the different amounts of X that you clip off the corners, and then on the vertical axis you could have the resulting volume. So X on the horizontal, volume on the vertical, and you should find that you get some kind of a curve. Then I want you to make the thing. So to obtain a good score for criterion D, the physical object will need to be well manufactured, and you'll compare your physical object with your theoretical volume that you got from the spreadsheet and argue whether it makes sense. I also want you to talk about the degree of accuracy that you work to. So did you go to 10 decimal places when you calculated stuff? If you did, was that a good idea? Was there any point to that? Or did it make sense to go to fewer decimal places? So a comment supporting the degree of accuracy you have worked to, and that is a direct strand from criterion D, as well as being something that's often asked on exams. And it's often overlooked by people doing the exam. So support the degree of accuracy that you've worked to.